X-rays. The Crookes tube that was used to study cathode ray tubes and that resulted in the discovery of the electron was also instrumental in discovery of X-rays. Wilhelm Röntgen was experimenting with various configurations of the vacuum tube in order to study the properties of the cathode rays. He shielded the tube with black cardboard so no light or cathode rays would emerge. He energized the tube and turned off the lights to check the effectiveness of the shield. And then he noticed that several meters away, a screen coated with barium platinocyanide, planned for later use in the experiment, was glowing. Röntgen knew that the glow could not be caused by the cathode rays, so he theorized some other kind of ray was passing through the shielding and causing this screen to glow. Because it was unknown, he just used the term X-rays, and very rapidly he tested other objects to determine the penetration power of these X-rays. This was yet another example in science where a great discovery was made by accident. And you can have a look on the web for other discoveries that were made like this. At the time of the discovery of X-rays, people had no idea that excessive exposure to these X-rays was dangerous, so many demonstrations occurred which we wouldn't do today. Only 2 weeks after their discovery, Röntgen took an X-ray photograph of the wife of his hand, Anna Bertha Ludwig, by placing a photographic plate behind her hand and directing X-rays at her hand. The developed plate would appear white where the X-rays penetrated and dark where the X-rays hadn't penetrated. Can you explain why the picture of Anna's hand looks like it does? On the right side of this slide, you can see the X-ray photograph of Anna Ludwig's hand again. In it, you can see the shadows left by the bones in her hand and fingers, as well as her very large wedding band. What we know from this is that dense materials such as bone and metal block X-rays, leaving a shadow, whereas other materials such as skin allow the X-rays to pass, and that leaves the photographic plate exposed and bright. So it kind of made sense that the medical profession might be interested in this particular discovery. X-rays were great. Physicians could now see bone damage without having to open up a patient. If a patient had been wounded by a bullet, the X-rays could locate them quicker than a doctor just poking around. There is a problem with X-rays though. X-rays have a great deal of energy and can knock electrons out of atoms, causing them to ionize. This can disrupt molecular bonds, can cause other kinds of chemical reactions to take place. So if you're X-raying a box to see what's inside of it, that's not a problem. But if you're X-raying a person, you run the risk of damaging tissue and causing, in high doses, some form of radiation sickness. That's why when you go to the dentist, the doctor is very careful to shield your body with a lead drape to minimize your exposure. X-ray usage is very carefully controlled to minimize its side effects. X-rays were the subject of much experimentation. For example, the materials of the anode in the X-ray tubes were changed for other materials to observe what might happen. In addition, the electric field between the cathode and anode was varied to see how that impacted X-rays. And finally, the X-rays were subjected to electric and magnetic fields and were found not to be deflected. So, what does all this say about X-rays? And in particular, what does it say about the charge on X-rays? When the X-rays were subject to electric and magnetic fields, it was found that the X-rays were not deflected. So that implied that the charge on X-rays must be neutral. In fact, later research showed that X-rays were not charged particles, but another kind of electromagnetic radiation.